Okay, so what is a linear function? It says a function is linear if the rate of change, also known as the slope, is constant between any two sets of points. On a graph, a linear equation is a straight line. So one thing I always point out is that the word linear, the first few letters of, or four letters actually of linear are line right there. So the word line is going to be mean linear, right? It's a straight line. And remember that to make a straight line, you only need 2 points. If I have 2 points, I can connect them with a straight line anytime. So we're going to use the equation y equals mx plus b most often. This is slope-intercept form, so I'm going to write that out here to the side. So slope-intercept form. This is on your reference chart, so you definitely need to become very familiar with it. So slope-intercept form. It's called slope-intercept form because from that equation you get two really important pieces. You get m, which is slope, and you get a b, which we use to refer to the y-intercept. So b is the y-intercept. So a y-intercept is where x is 0, so it's going to be always be 0, comma, some y value. So the y-intercept is always where the line crosses the y-axis. So y-intercept. So again, slope-intercept because you have the slope and the y-intercept. Sorry, my e's are not coming out very good today. Okay. So on the next little section, it just says a linear function has a blank rate of change that is constant. Again, I said that in the first section. I'm going to say it again. So a constant rate of change. So constant. So a constant rate of change. To find the rate of change, you simply find the ratio. So the word ratio is really important. A ratio is just a fraction. So we're going to make a fraction that usually is going to stand for rise over run, which is on the little section below. So in other words, rate of change or slope, which is also represented by the letter m, means all of those things. So every single one of these things here at the bottom can be used to describe slope. So the change in y divided by the change in x, the change in f of x divided by the change in x, a vertical change divided by the horizontal change, rise over run. This is what I'll say most often. And then this right here just says change in y divided by change in x. That triangle is the symbol for delta, and delta means change. So just know this is an abbreviation for change in y divided by change in x. So what do linear functions look like? So there's a couple of examples there. First, a graph. A graph is just a straight line. It doesn't have to be a straight line that's increasing. It could be decreasing. It could be horizontal. It could be vertical, but it's a straight line basically. So a linear function is just a straight line. An equation, it doesn't have to look just like this, but this is in y equals mx plus b. So this is slope-intercept form. Really important that you understand this equation right here does not represent that graph. So those are not the same. This line would be negative. See how it's negative? So a negative slope would be decreasing. So just know that those two are not matching. Okay? And then it could be a table. So we're actually going to get a table for this equation. I really wanted to introduce this pretty early, so I'll need you to know how to put this in a graph and get a table. So that's why I have my calculator open. So one really important thing that you understand before we type this in our calculator is that this y right here, remember last week when we were doing function notation, we talked about how in function notation, f of x is the same thing as y. So I can just replace that y with f of x equals negative 2x plus 5. So this is the same equation, y equals negative 2x plus 5, or f of x equals negative 2x plus 5. Those are the same thing. It doesn't matter that it says y and this one says f of x. Either one of those is fine, but my calculator is going to use f of x, and I want to use f of x whenever possible. So what we're going to do is we're going to go to our calculator, and we're going to graph this line. F of x equals negative 2x plus 5. So my calculator, I'm going to add a graph. So if you're at the home screen, you would do a new document, add a graph, And notice there it is. It's in function notation. F of x equals. That's why it's really important that you understand that y and f of x are the same. A lot of students want to delete that, and you don't need to. You can leave it. So we're going to type in negative 2x plus 5. And when I push enter, I get a line. What's really great about it being in function notation, so f of x, is that I can get a table of values. If it's not in function notation, I can't do that. So to get a table, when you type in a function, you're going to push, there's several ways, but the way I'm going to show you is, I think is the fastest, is to push Control T, T for table. And there's a table of values. So notice it starts at 1, but my table here starts at 0. So the way I get back up to 0, notice it's going 1, 2, 3 down the column over here. This is my x column. This is my y or f of x column. I'm just going to go over to the x column and I'm going to go up. So you can scroll up and down if you need to, if you need different values. So please don't think just because your table starts at 1 that that's the only thing you have there. Definitely not. Okay. All right, so we're going to fill in our table. So we need 0. So right here on my table, notice when x is 0, y is 5. So I'm going to write that in. So x is 0, y is 5. When x is 1, y is 3. When x is 3, notice I skipped 2 here. When x is 3, so I'm going to go down 2, y is negative 1. And when x is 5, so not 4, but I'm going to go down till I get to 5 right here, 5, y is negative 5. So negative 5. Okay. All right, so another way you could do this without getting the table is by tracing. So we did that last week, but just let me refresh your memory on that. So if I want to get rid of the table, I push Control T to get the table. I push Control T to get rid of the table. So I could just trace. I could do menu, trace, graph trace, just like last week, and I could have gone to 0. So remember, I just start typing 0, x equals 0. Yes, that's where I want to go. So I'm going to say enter. 5. Then I could go to 1, enter, 3, exactly what we wrote here. Then 3, enter, negative 1, and then 5, enter, negative 5. So just know if you want to trace rather than get the table, that's an option also. Those basically are the same feature. Okay, so that could be a table of a linear equation. So we'll talk a lot more about that here in just a minute. Okay, so moving on, we have a couple of examples here. So we can use word problems to represent, or linear equations to represent word problems. So here's our first example. Little Jimmy is saving money to buy a new toy. The table below represents his savings over X weeks. So what I see from this table, if X is weeks, right? So X is weeks, you might write that in there. So X is number of weeks. And this then would be his savings or his money. Okay, so at 0 weeks he has $2, so that means he already had $2. At 2 weeks he has $8, and at 4 weeks he has $14. So they're asking for the rate of change. So just a reminder, that rate of change, I'm going to scroll back up for just a second. Rate of change is the change in y divided by change in x, which is exactly what this down here means. Change in y over change in x, or the vertical change over the horizontal change. Every single one of these is a way to represent that. But we want change in y divided by change in x. I'm going to go back down to my example here. So I'm going to find his change in y divided by his change in x. I'm going to write it like this. Change in y divided by change in x. So if I look at his y, right here, from 2 to 8, if you don't know what that change is, you would subtract. You would do 8 minus 2, go backwards. So from 2 to 8, hopefully you realize there's a change of plus 6. So my change in y is 6 divided by my change in x. So his change in x is from 0 to 2. So from 0 to 2 is a change of positive 2. So our change in x is 2, and then we just simplify over here. So we want to do the change in y, 6 divided by 2 is 3. 6 divided by 2 is 3. So we're going to write that over here, 3. So the rate of change for this is 3. And if you check that for the next one, it should be the same. If this is a linear table, then these should be the same. So if I try that again, 8 to 14 is plus 6. 2 to 4 is plus 2. And 6 divided by 2, again, is 3. So the rate of change for little Jimmy and his saving money is $3 per week, right? So it's $3 right here, or $3 per week. 6 was dollars on the top. On the bottom, it was weeks. So he's saving $3 per week. So I'm going to write that here. His rate of change is $3 per week. Okay. All right, then the y-intercept. So the y-intercept, if I go back up to the very top right here, y-intercept, I said that a y-intercept is when x is 0. That's really, really important. So going back to our problem here, our y-intercept is going to be where x is 0. I'm going to just encourage you, every time you get a table, that point is maybe the most important. So our y-intercept is 0, 2. So y-intercept is 0, 2. All right, so we can write an equation in y equals mx plus b. So again, in y equals mx plus b, our m is our rate of change. So our rate of change is the m. And our y-intercept is the b, and we would just plug those in for m and b. So our equation in y equals mx plus b is going to be y equals, our m is 3, x plus our b is 2. We don't have to put the 0 in, just 2. So y equals 3x plus 2. All right. We definitely should be able to graph this without a calculator. But I'm just going to encourage you to please use your calculator to check your work. So y equals 3x plus 2. So without a calculator, what I know is my y-intercept is 0, 2. My b right here is 2. 0, 2, and 2. So my y-intercept is going to be at 0, 2. So on the graph, let me zoom in. On the graph, that means I start at 0, 2 right here. This is 0, 2. I'm going to label it 0, 2. That's our y-intercept. From there, every single week, little Jimmy is saving $3 over 1 week. So from this point, we're going to go up 1, 2, 3 over 1. So our next point would be right there. And then same thing, we're going to go up 3 over 1. So up 1, 2, 3 over 1. So the line that's going to represent little Jimmy's savings would look like that. We're just going to connect those all together. So look like that. If I were checking that in my calculator, I would just go in my calculator and I'm going to type in y equals 3x plus 2. And we should see that it looks like what I put on my paper. So if I'm going in my calculator, remember I already have this graphed. So a lot of you were struggling with this last week. I can push tab. It's automatically going to go to the second function. So I can just go back up, right? I need to go up to go to F1, and I can delete this right here. I would delete to the equal sign. If I push delete one more time, it's going to ask me to choose this, and I don't want to do that. So don't delete the equal sign. We want to leave it in function notation. So push escape if you accidentally do that. Okay? And then we would type in our equation. Remember, f of x and y are the same thing. So our equation was 3x plus 2. Enter, and you should agree that this graph on our calculator looks like this graph on our paper. If you wanted to just make sure, you could trace to get a couple of points. So we could do menu, trace, graph trace. So 0, 2, that's your y-intercept. It's always going to be the first point. Then we could go to 1, and our graph right here is at 1, 1, 2, 3, 4, 5. So 1, 5 should be the next point. So when I go to 1, 1, 5, there it is. Then the next one should be up here at 2. I believe that's 8. 1, 2, 3, 4, 5, 6, 7, 8. So at 2, enter, 2, 8. There it is. So this graph on our calculator does match what's on our paper. Okay? All right. So let's look at the next one. Given the graph, identify the following pieces. So we need the rate of change. Again, rate of change is slope, the y-intercept, and the equation. So I'm going to do the y-intercept first. I personally think the y-intercept is the most easily recognizable point. So again, the y-intercept is always going to be 0, comma, some y value. So this is where x is 0. So x is 0 right here at the origin because I haven't gone left or right. So the point that is at 0 is right here at 0, comma 2, just like on the last one. So just coincidence, but 0, comma 2 is our y-intercept. Okay. Our rate of change is going to be our slope. So we need to find another pretty point. So we have one point, we need another pretty point. So by pretty point, I mean it has to go through like the corner of the graph, like right there or right here. Those would all be pretty points. Right here would be a pretty point. So we're looking for a point on this line that goes through a pretty point. So that right there is not a pretty point. This right here, not a pretty point. This right here, also not a pretty point. It looks close, but it's not. This one right here is going to be the next pretty point. So really important that you see what those pretty points are. Don't just make something up. You got to actually find it. Okay. So we're going to count from here to here. What is our rise over our run? And then I'll show you how to put that in the table and check that. So from here, we're going to rise up, right? We go up, 1, 2. So our rise is 2 over our run, 1, 2, 3, 4, 5. 2 over 5. We went to the right 5, so that's positive 5. So our rate of change is 2 over 5, or 2/5, and that is perfectly fine to leave it as a fraction. So we're just going to leave it as 2 over 5. So our equation, again, in y equals mx plus b. M is our slope, that was 2/5. B is our y-intercept, that was 2. We're just going to plug those in. So it's going to be y equals 2 over 5x plus 2. Our y-intercept is 2. So now that I have this equation, I can actually use my calculator to help me and make sure that I got that right, that these numbers, so I have a point at 0, 2 and a point at 5, 1, 2, 3, 4. I'm saying that there's a point at 5, 4, so we can use our calculator to see, does this equation match that information? So I'm going to go to my calculator, I'm going to push tab, because I already have this one graphed, I want to get rid of that, so I'm going to push tab. I'm going to go back up to F1. I'm going to delete all that to the equal sign. Remember, if you accidentally delete the equal sign, push escape. You don't want that. Okay. So we're typing in 2/5, so control divide to get your fraction bar. 2/5, then x plus 2. 2/5 x plus 2, and then enter. So definitely looks like that, right? We could agree that this looks similar to that. They're both increasing from right to left. Notice we have a point over here. We could have used that for our slope also. So that's at -5, 0. So let's check that. So if I trace, menu, trace, graph trace, I should be able to trace to -5. So -5, enter. There it is, -5, 0, just like on my graph right here, -5, 0. Then I should have one at 0, 2. So I'm going to go to 0, enter. 2, that's there also. And then the other one I had on my paper was right here at 1, 2, 3, 4, 5. 1, 2, 3, 4. So let's check that. 5, 4. So at 5, 4. There we go. So let's fill in our table using our calculator. So we already know 0, 2. Let's scroll up on my paper. 0, 2. Already got that. We already have 5, 4, and we have -5, 0. Those all came from the graph. So -5, 0, 0, 2, 5, 4. So now we need -10, +10, and +15. So -10, so I'm just going to go back to my calculator. -10. I'm already tracing, so it'll automatically go there. Enter. -10 is at -2. So go back to my paper. -2. And then I want +10 and +15. So I'm just going to go back to my calculator. +10, enter, is at 6. So I'm going to write that on my paper, 10, 6. And then at 15, enter, 8. All right. So there we go. There's just a few basic steps on using our calculator to figure out information about linear equations.